with now. We have Ananth Prakash as well as the Mr. Santosh. We'll have the introduction of the both the speakers.
Dear colleagues and esteemed participants, it's a privilege to introduce Mr. Ananth Prakash T. With over 2 decades of experience in network, telecom, and storage. He is excelled as a technology director for the Compute and Network Innovation Group. Mr. Ananth Prakash T is known for his passion in architecting secure connectivity solutions for automotive and IoT and leading 4G, 5G telco edge infrastructure projects with GPU offload at MEC. He is also a dedicated volunteer and associate council member at Each One Educate Foundation. In his leisure, Mr. Ananth Prakash T enjoys cricket, badminton, and reading. We are privileged to have him as our guest speaker today, eagerly anticipating his valuable insights. Please join us in welcoming him warmly. Welcome to you, sir.
Yeah, thank you.
And it's our pleasure to introduce our next speaker for today's session, Mr. Santosh Kumar R., a seasoned professional with over 2 decades of experience. He specialized in telco solutions, including cloud, NFV, 5G core, and cloud native application orchestration. Mr. Santosh has been instrumental in developing CI/CD platforms for cloud native network functions. In his leisure, Mr. Santosh enjoys reading and embarking on long drives. We are honored to have him as our speaker today, and we eagerly anticipate his valuable insights. Please join us in extending a warm welcome. Welcome to you, sir. Ananth Prakash, sir, shall we begin, sir?
Yes, we can. So,
Yes, sir.
shall I share my screen? Is that
Yes,
fine?
sir, please.
Okay. My voice is audible, right? It's all clean now.
Yes, sir, it is audible.
Great. Okay. Just so now it's in full screen mode, right? You are able to see it clearly?
Yes, sir.
Great. Okay. So, hi all. Thank you so much for giving this opportunity for us. It's our pleasure to be with such an august audience where I consider I get to hear that you're all on ECE and inspiring younger youths to take up their journey into the life of telecom or communication industry. So it's my privilege, and thanks to Santosh too and people who facilitated this opportunity. Whatever little we have gathered, we would like to share it to you. Feel free to ask us questions. Feel free to stop. Maybe if I'm not able to hear your query, leave it on the chat, then maybe we can have it on the QA sessions. Okay. So getting back here, because seeing the background that you're already in the EC area space for many years now, I will assume that basic things are with you so that then we will take off from one place, right? 5G, coming to that. So 5G is such a big hype, a revolution that people call it. And most importantly, it's unlocking the digital age of the whole world, not just India. You could be seeing that even Pradhan Mantri made a big announcement. Government is making a whole investment.
Recording in progress.
Okay, cool. Recording. Right? So it's a huge investment. Everybody is getting behind this. So what is it that 5G is bringing to the table is what we need to understand today. So maybe we'll embark on this journey. Okay. So somebody might tell me, 1 second, why is it not moving? Okay. So coming to the next slide. So 5G is a revolution. Why is it? Right? Is it just an incremental flow that is happening from 1G to 2G to 3G to 4G? Is it just that? Or is it something different? Why is there so much hype? What is that that's going to really bring in? Or is it just a fake hype that people are calling just for making business out of it? So that is a question that we want to answer today. And what I would like you to imagine when we are getting to this topic is just imagine that aeroplane is being assembled. Okay, when you're trying to assemble an aeroplane, maybe that is called as 2G. People are trying to figure out. Wright brothers discovered aeroplane. They figured out, oh, aeroplane is nice. They tried to manufacture it and they tried it out. That was 2G world. 3G was just incremental, getting it things done. So voice communication started happening. But there are some things, that's why we call it as connected hardware. It was kind of optimizing the hardware and getting the aeroplane to get ready in a platform. But 4G was something little different. Can you, any of you tell me, what is it that 4G brought into the world that really started making people think differently? Anything that comes to your mind? Because in the 3G world, you might be seeing what mobile phones that we used to have, right? Maximum was used for teleconference. We used to call, speak, voice calls, and max that could support was message. But what 4G brought into the system is packet-based communication. It was a concept shift from a voice switching circuits to a packet-based protocol wherein applications, smartphones started evolving. And once that smartphone started evolving, you can have Skype, you can have WhatsApp now, you can have video calls now. So it just changed and revolutionized the world. So it brought in everybody, and everybody is using 4G now. 4G is the thing. You can see the UPI came in now, even digital transactions are going on, all that. So 4G did that. If 4G is able to do that, what is it that 5G is going to do, right? It should not be just an incremental step. It should be something drastic, a leapfrog. And 5G is doing that. How is it doing that? It is going to bring in now devices to devices, 50 billion connections it should be able to sustain. And mobile data is going to shoot up by 1000x, and it should be able to sustain that carrier. And it is going to have a low latency. It is not just 1x, 2x, it is 5x low latency than the 4G that provided you. And end user data rates, earlier it was 1 Mbps or 2 Mbps or 10 Mbps. People are now talking about Gbps, right? So these are the kind of industry transformation shifts that 5G is going to bring in from the concept of telecommunication evolution, okay? So, but now I want you to pause. Is it just this? Is it that 5G bringing only this much? Yes, of course, it is going to be a very fantastic thing. But is there something much more that 5G is going to bring in so that the whole world is converging it? Because earlier, if you look at the history of it, because I want you to look at and appreciate the history, because history tells a lot about what is the future trend that's going to be. Earlier, if you look at last 10 to 20 years, telecom industry was being ruled by very, very countable number of people. Say AT&T, Vodafone, Nokia, Ericsson. So these kind of companies. But today, when you're talking about 5G, what are the kind of companies are wanting to enter this? Are you able to think of few companies? People like Microsoft, people like AWS, people like Google. These are the kind of, so they were traditionally known as cloud companies or data center traditional companies. Now, what is that they are going to have, and what is that they're trying to achieve by getting into 5G? Rather, if you want to ask it in a different way, hey, you guys are not telecom. Telecom was Nokia, Ericsson, AT&T, those kind of guys. What is that these guys are offering now? What is that they can offer? So then it makes you think that there is something different happening in the industry. It is not just evolution of voice, not just evolution from a normal text messages to WhatsApp kind of messages or video calling. There is something more happening in 5G. And that's where there is a lot of huge, and every industry wants to have a pie in it and contribute to this evolution. So with that kind of a statement, now I'm trying to broaden your thought horizon, right? So I wish if you could have a one-on-one session, or maybe physically be in front of you so that we could have really good interaction. But anyways, I'm assuming that you're with me, okay? So going with the flow, I put this basic question. I want you to start thinking now, what is it that happened that is making people like software industry guys like Dell, Microsoft, Amazon, Google, these are just naming big guys, okay? So that assuming that you all know those names. There are so many other software industry companies also entering this space now. Not only them, automotive industry is entering. Not only them, IoT industry is entering, industrial revolution. That's why they called it as, it is just not a telecom revolution. It is a fourth generation industrial revolution. I want to drive in that point into each one of you. Shifting from 2G to 3G, yes, it was great. 3G to 4G, yes, it was fantastic. Everybody is having a smartphone now. But 4G to 5G is just not a telecom revolution, it is an industry revolution. So that's why I'm trying to spend so much time on this slide, because I want to drive home this point. You guys, EC communication professors or teachers or innovation guys, research, R&D, everybody, you are going to bring about a new dawn of the world order, a new way of working culture you're going to bring in. And that's why rightly named fourth industrial revolution, 5G, okay? So now when I give so much of hype to this 5G, before getting into what is extra things that 5G is going to bring in, maybe I will take you back in the history of data center world, how the whole thing evolved, so that you can see what is it that's getting converged to. Okay, so I'll take a pause on the telecommunication space now. I'll switch over. What is it that the data center industry or a storage industry or a networking industry, what is that was happening there? Okay, what are the key inflection points that happened? In the case of 1990s, PC revolution happened, because the very minute that personal computers came in, it revolutionized the world, right? You're all with me in that. Mainframes from there, individual desktops. So Microsoft made a huge killer there, and every house, every company started having a PC in their desk, which was not imagined earlier than 1965. And after that, what happened? Somewhere in 1980s, Linux came and did something different. What did they do? I'm sure every one of you have the answer. They opened up the operating system. They made it free. They made the concept of operating system to everyone. Anybody can write apps. Anybody can understand how the kernel works and all that. See the beauty in that? By opening up, by sharing your knowledge to somebody else, you are creating a bigger, larger ecosystem. That is the message here, right? And that's what Linux brought about, where Microsoft OS was earlier a closed operating system. No doubt it brought in a lot of changes, but Linux created another wave of getting in college grads, R&D companies, everybody to get in, because it is free, open source, and you know what the operating system does. So that was one inflection point in the history of mankind. And after that, open source came, Linux came. Yes, 1990s, it evolved. So every engineering companies, early R&D company, very easy to prototype your imaginations, right? You can try it out even before you come into production. And something wonderful happened sometime in 2003, 2004. Slide is sharing that, a VMware, a fantastic company, though many people were toying with the idea of virtualization. What is that virtualization they brought in? Can you all share that? What is that? Earlier, there was a physical laptop or a physical servers. You could install only one operating system and only few guys could log into that and work. I couldn't have a server wherein applications of Windows and applications of Linux both couldn't work simultaneously before platform virtualization is brought in. So virtualization was a fantastic concept. Though many companies were contributing this innovation, VMware took it and made it really big, made it production grade. So once they brought in virtualization, optimization happened, multiple OS came in. So hardware vendors started becoming commodity. That's why we call it commodity off the shelf. So they started bringing standardization on the hardware so that you can put any kind of hypervisor virtualization on it. You bring in your operating system, and any operating system, if you follow these guidelines, it will work on this platform. And that's the innovation, right? So that was a thought process shift that happened. And after that, what happened? Slowly from the hardware, now that PCs were able to virtualize, slowly started going deeper. Deeper is what? Network industry. Networking, Cisco was a huge thing. The whole network boxes were owned, deployed by only one company or one or two companies. But Arista was a very small startup. They came in and made a software as a virtualization again. You don't have to really have a hardware switch, which will do a Ethernet packets or IP packets to be switched. You can take any Linux machine, like you're in Bangalore, so you understand. You go to SJP Road, JP Road, get any server on it, take a software, download it. It is a switch software. That server will behave like a switch now. So that was the revolution that they brought in. So kind of what they did, they again revolutionized and brought about open SDN, software-defined network switches. They again opened it, they standardized the whole thing. So they broke the proprietary concept of it. And that's the key here. And having done that, there was a next age of revolution that's on the data center industry world, which is called as cloud, right? Earlier to them, what happened? Every bank, every company used to have their own data center, managing their own data, managing their own stuff, including your college. You had your own data, your own machines, everything. But imagine that you are a small startup company, you can't buy so much of servers and keep it. How do you do it? And that is where Microsoft, Oracle, Google, they said, okay, your knowledge, your strength is not in managing servers. Your strength, your key skill set is not in managing switches. Don't worry about it. I will give you a login web browser. You log in, you spawn your VM automatically. You don't have to bother whether that virtual machine is in Bangalore, it is in Delhi, it is in Calcutta, or US, or London, or Australia. You don't have to worry about it. You want 20 core CPU, 500 GB RAM, 200 TB disk, hard disk, you get it on the fly, click of a button. And that is what cloud industry brought in. And that was fantastic innovation. You opened up. So the banking industry or any enterprise industry, you took away a huge load from their mind, right? Because core strength of a banking industry is banking. Why should they worry about setting up a server and making sure that server, that banking software is running fine? That is not their core strength. That is offloaded to a cloud company. And they are good at it. Amazon is good at managing the servers. Cisco is good at managing the servers. Oracle is managing good. So let them do what their core strength is. Let the banking guys take care of banking softwares, or any other company take care of their things. So that was a shift that brought a cloud wave. Okay, from 2010 to 2015-16, it was a shift, migration from a normal traditional data centers to a cloud. And once when that was happening, 5G started catching up. And what is it that brought in, right? So this is what I was trying to explain you, that initially you had a normal bare metal hardware, you had a OS, and you had a single application. And next what happened, hypervisor, that is virtualization for the hardware came in. So you have a thin layer of OS, virtualize the hardware, so COTS, commodity off the shelf servers, right? Now you can have multiple VMs. VMs is what? One could be Windows, one could be Linux, one could be CentOS, anything, whatever, Citrix OS, different. All of them work simultaneously, seamlessly, security safe. That's the key here. Okay, let me get into my pointer so that you are with me. Okay, so that is the revolution that brought in that VMware. And now what is happening? When the cloud came in, people started having a lot of difficulties. What is the difficulties that people started having? They migrated to the hypervisor, but banking companies had their own applications which was running on their proprietary operating system. And like that, say school application, you have small application, parent teachers meeting application, attendance, everything became software, but it was running on a guest OS, your own operating system, and maybe a version is old one, but current one. So your application may not run in the new OS, it will work in Windows, but it will not work in Linux. So these kind of challenges people started facing when they really wanted to migrate from a private data center to a cloud kind of environment. Because people didn't want to tie up only with Amazon. People didn't want to tie up only with Microsoft because, see, Ganesh Chaturthi is coming now. So Amazon is giving a lot of freebies. 1 year, say 100 servers free, up to 10 hours of usage. Now, so you bought in for that, but say next time Navratri festival is coming or Christmas festival comes up, so Google will come and tell, okay, you use my data center, 2 years I'll give you free. 100 GB free bandwidth also I will give. So seeing all these kind of offers, using compute on the fly, people felt I should not be tied up with one single cloud vendor. I want to have my applications run on my premises, private data center, or on Google Cloud, or on Amazon Cloud, or any cloud. My application should be seamless. Today I will launch it here. Tomorrow I will launch it somewhere else. It should work. It should not create problem for me. And that created a new kind of innovation. We call it as containers, cache layer, container as a system service, right? CNI, cloud native applications, we call it. So you don't have to worry. So it removed the logic of hypervisor. It removes. What is another thing that is happening? There is optimization, right? You are all ECE guys. So you are the hardware dudes, right? But what was happening in the earlier process? You had a hardware, you had an operating system, you had a hypervisor, and again on the top of hypervisor, you had multiple OSs. And on the OS, you had applications. So how much of latency, how much of resource wastage was there, right? So you cut all that, remove all the multiple different operating systems, have one OS on a hardware, and have your container native cloud application layer. We call it as CAS layer. And on the top of it, you can run any application, be it Windows kind of application, we call it container. So you have to follow a few rules, write your application container based. You can run it on Google Cloud. Immediately today evening, you move it to Amazon Cloud. Tomorrow evening, bring it back to your college private data center. Application will work seamlessly without nobody knowing what is happening. So this is the revolution that data center industry brought in. And at the same time, 4G to 5G spec was being created. 4G was becoming a huge hit. From an auto wala to a taxi wala to a very rich man to a banking professional, everybody was getting adapted to smartphones because you could do voice calls, you can have applications installed. So now, slowly you can see the convergence that's happening, right? Data center industry is converging from on-premises to cloud, from any cloud to any cloud. Application transformation was happening. Now a new device came into the picture. Are you able to see the history that's coming in? The new device is what? It is not server, but it is behaving like a server now. Server on your palm. That is mobile. Mobile started becoming so smart that it is already behaving like a x86 server, like a laptop. Mobile is as powerful as a laptop today. You had iPads, as good as a laptop now. So telecom industry people, when they were writing 5G spec, they came and started asking, hey guys, you are now converting all your applications to be cloud native. Can you make it mobile phone native as well? Logical question to ask, right? Initially, there was little pushback, and then data center industry folks saw a huge opportunity here, and they wanted to take a pie out because now they can provide your application from a service, application as a service, cloud as a service. Now application can come, work on your mobile phone, again be switched back. When you don't want to use it, push it back to the cloud. Use the compute power of mobile phone, or if you want to offload the compute power of the application running on a mobile phone, you offload it to a cloud. And if cloud is charging you more, bring it back to iPad or whatever. So this kind of seamless transition people wanted to bring in, and that's where the telecom industry and the data center industry started to converge. And that's why the right term, it is a fourth generation industrial revolution that 5G people accommodated it and they are bringing about. So with that prelude, now let's switch over to how telecom industry is getting disrupted, if I want to call it. Because once data center guys entered, they started asking 1,000 questions to the good old guys of Nokia, Ericsson, the way they were doing. Why? So let's see what were the kind of questions that they started asking and what is the kind of answer that telecom industry as a spec, ITSIA or whatever is 3GPP started responding to, right? Coming back, what was 4G doing? 4G went to the consumer hands, it revolutionized, it became smartphone, from a regular phone, from a text-based messages to video calls to application smartphone, right? And it started connecting internet to mobile phone, which was not there earlier. Fantastic thing. But what is it? It was still under the control of people like Nokia, AT&T, Jio, or Airtel kind of guys. It was centralized. Whole technology was proprietary. Every centralized, owned, controlled everything. But consumer was started asking, I want to be able to run my application on mobile or in the cloud. Please help me out. But telecom industry was still not open for it. So it was centralized. And all their servers, all their applications were running on a bare metal or virtual. They were also undergoing into virtual, but still it was proprietary, managed in a private data centers. And that was how 4G was. Yes, no doubt, on the top three, they were very good. And the bottom three, though they facilitated, brought about a great change, but still there was some control, centralized control that they were trying to hold, right? But the minute they allowed data center guys to talk in to their office, start walking into their office, started questioning them. What is the kind of new revolution that they started questioning it? Can I use mobile phone and connect it to my enterprise data center? They wanted to throw a small, you say, bait, fish bait, because telecom industry was not opening up to the world. So what did Google, Amazon guys started telling? Hey, look, if you allow me inside, what I will allow you is from your iPad, from your mobile phone, I will allow you to connect to any data center. You just run your applications and look how your applications are running. You can give a command. You can log into a Linux server remotely and log into your command. So enterprise, I will give you access. So it is like a telecom industry can make money out of it, right? Because telecom industry's money making business is in communication, connecting people, connecting networks. So they said, there is an opportunity for you to make business. I will give you that. Allow me to enter your space. It's kind of luring thing. That's how they entered it, by giving that connectivity to enterprise, opening up enterprise to the mobile phones. And not only that, the embedded guys, IoT, the surveillance camera, suppose a lot of terrorists attacking. So whole of, say, airport systems, they wanted to make sure what all the sensor data is being done, analytics to be done in the cloud. And if you find any dangerous person or dangerous thing or unknown thing, automatic message should go to the in charge, security in charge, or personnel in the airport should get to know that, oh, there's the issue, there is somebody intruding into the system. So IoT started becoming, and not only that, gaming industry, AR, VR guys. So that was, they also started entering. Now coming back and consolidating, what did the cloud guys started asking the telecom industry? They said, see, your hardware is proprietary. Open it up. Tell me access, how I can run my application on your servers, how you can make it decentralized, how I can virtualize your application, and so that Google also can make application, or you can also write application and run on their servers. So mobile edge computing, if you know, it is a fantastic space. I would encourage you to go and read on that. So how to come in? So distributed edge started becoming a big concept, and they started giving multiple use cases for it. And for all the top ones to work, all applications should be cloud native, because it should be able to run on any hardware, any device. So that's the idea. That's why it is bringing in a revolution. That's what I would call it. So if people call 4G was an evolution from a 3G, from a technology perspective, 5G is a revolution and disrupting the telco and bringing the whole world together, connected world, right? So it's an evolution to revolution transition that's happening, and we are at a fantastic position. We are at the inflection point of it, right? So coming back, trying to see what is that 5G architecture bringing about compared to 4G architecture, enabling all the top 5 important features that I was talking about, right? One is, of course, frequency bands. Earlier, it was lower frequency bands. Now we are moving into millimeter wave. So what is the advantages? What are the challenges of a millimeter wave? You guys are experts in ECE, so I assume you will know it. What is the challenge? To name one or two, because you are going to high frequency, you cannot have larger distances, right? You're at lower frequency, your reach is larger. You are at a higher frequency, your reach is shorter. Very, very basic science behind this. Next, what is that they're going to bring in? Network architecture, service-based architecture, because it was everything should work on the cloud as well. Applications should be able to move seamlessly. I should be able to do mobile edge computing. I should be able to do it. So it should be a service-based architecture. Application should be able to seamlessly from telco servers to outside and back and forth. So earlier, it was a monolithic architecture controlled by few top telco industry world, which ruled the world for about last 30, 40 years. But now they have to open up. So monolithic to service-based architecture, a very, very major shift. Next is network slicing. I will leave Santosh, our architect, to explain on the network slicing, what are the different use cases that's bringing about, which 4G was not able to. And most important is URLLC. That is, earlier, the latency was at 30 millisecond or 1 second kind of a thing, 50 milliseconds. Now we are talking about sub-milliseconds, less than 1 millisecond response time. I say hi, it should touch your mobile phone and come back to me as a response. For critical applications, for latency sensitive applications, For critical IoT applications, I would need URLLC, ultra low latency. And not just that, now video call with grandparents in India and their children in US. Like, where are you now? They just do a face call. Mama, I am there. My grandson is playing in this park today. So video calls have become so common today. Very recently, suppose now Asia Cup is going on cricket. So you would have gone, suppose you got a ticket and went to Sri Lanka to watch India-Pakistan match. You would like to show it to your friends that you are in the ground. You want to showcase. So log into Facebook, put on the video and showcase the live cricket match being played. And that's becoming a very norm today. What is that demanding from you? Earlier 4G couldn't sustain this kind of very high video bandwidths, but it is a demand from the 5G. You should be able to touch maximum of 20 Gbps per second. And 20 Gbps per second, not just one guy. If you're at a stadium, 10,000 people, 20,000 people, maximum you will have 4 or 5 towers. Should be able to hold the load, right? So it is a Gbps peak. At the same time, number of connected devices. 1 million devices, 30,000 devices, mobile phones, including surveillance cameras, all are pumping data out and all are kind of video streams. So peak data rate and sustained peak data rate for a massive number of devices. Biggest challenge on the 5G and architecture is supporting it today. And all these people want by selling out less money, right? Money, energy is most critical. So people want to save energy, power cuts, all that is a very green. What is a green energy? All that a lot of people are talking about. So energy savings is very highest important. And that is another thing, that network slicing and massive MIMO, multiple inputs, multiple output. What is that? What are the features that brings into you? All that we will get to know as we jump into the architecture of it. So with this architecture difference between 4G and 5G, let's go and see what are the different kind of industry spaces. Because no, I can't give very high bandwidth to 10 million people. Impossible. You can't have your cake and eat it too, kind of, they call it, right? You can't have everything in one go. So what they did, they considered all the requirements. They tried to come up with a framework and they said, yes, I will tune stadium kind of deployment of towers to say enhanced mobile brand, because there will be 30,000 people, 25,000 people, but they will not be there 365 days there, only during the matches, right? Cricket match or football match or some big rallies going on, political rally. So that time there will be huge, or music concert. So enhanced mobile brand, you should be able to give a high peak data rates and 10,000 plus traffic. And if you can't give 10 Gbps, at least minimum required is 100 or 200 Mbps for 10,000 people or 20,000 people you have to sustain on one tower. So like that, I will calculate what is the capacity of the stadium and put so many towers across, and this is what we call it as SLA, service level agreements. I commit that I can sustain 30,000 people in the stadium with this video traffic, and this stadium guys per ticket, they will pay the telecom industry guys for the investment. They will get it over the year or over 2 years money back, right? So that is what we call it enhanced mobile broadband. That is one area where 3G spec is there and you do deployments that kind. There another kind of industry which 5G is also, we call it as URLLC, ultra low reliable, ultra low latency, less than 1 millisecond we called it. That is for machine industry, because machines are high precision. Say manufacturing industry or defense kind of things, for them, precision and reliable. These are the key factors. So normal towers that you put in cricket stadium will not work there. In cricket stadium, suppose you are playing the live mobile phone, Virat Kohli is about to hit a sixer. Say your friend is seeing that sixer after 1 second, it is okay. You don't care. But in the case of a car manufacturing company, if you, in 1 second, if you don't give a fault, maybe the whole batch of Maruti car being manufactured might go for a toss, right? All doors could be wrongly fixed. Or say aeroplane is going to crash land if you give a wrong signal to it. So I'm just giving you some examples. Our architect Santosh will give you more on those. So that's another industry space, low latency space. And at the same time, there is another, we call it as massive MIMO, massive communication, like kind of IoT devices, where we are looking at 100,000 200,000 kind of devices to be able to continuously stream, but not high bandwidth. It will be like a street lights, or in the park, some sensors. So they'll keep on sending some data continuously, or windmills. Continuously, they are sending thousands and billions of sensors, but they don't expect to be low latency. They don't expect to be reliable. It is okay if they're not able to work for a day properly, but there are millions, so it covers. So this is a different kind of. So this is the kind of multiple industries, 5G, different characteristics that's going to support, right? So coming back on this, as I give you a big picture, now how is the kind of industry that's going to implement this? At your home, you could have a small cell kind of deployment. Small cell advantage is it can service only your home. So instead of Wi-Fi, you can replace Wi-Fi with a small cell. So tomorrow, maybe the world will look at you will carry a tower in your hand. A mobile phone can become a small cell tomorrow. I'm just extrapolating, but this is how I want your imaginations to grow. That's where innovations happen, right? Or you could have a macro cell kind of deployment, sub-millimeter wave in a deployment of a stadium kind of scenarios. And another fantastic thing that 5G brought in. What is that? They're just not fixed at low frequency. They also are in the low frequency bands, that is sub-gigahertz band, you call it. Also, industry did a fantastic thing by going from 24 megahertz to 100 megahertz or 25 megahertz, a higher frequency, and they created multiple bands. And another beautiful thing they did there is they created a private 5G license. A big company, a shipping company or a port or an airport can have their own 5G implemented for all their sensors, all their employees, and all the secure data of people entering the airport, exiting the airport, ticketing system, and all that, so that people like terrorists or somebody outside cannot hack into airport. You're able to appreciate that? And at the same time, on the ports also, they can have their own. So advantage of having your own private 5G is I don't have to pay money to Airtel or a Jio or AT&T throughout the year. It is one-time investment cost. And once I've installed number of towers inside my port, I take the license on a lease basis from private 5G license, and that's it. I'm secured now. No outside entity can break into my. That's where security comes in, right? I was telling security is a very, very critical thing now in this digital age, because people can intrude into anything from your mobile to your bank accounts to your company, country, and government or your banks, right? So that, I think I'm taking too much time. Coming back here. So the same thing that I explained here, I'm trying to, please don't mistake, feel free to ask questions. What I'm trying to do is from the architecture point of view, how telecom industry was growing, how data center industry was growing, how they're converging and creating a totally new use case, new space for the world. And I think this is a picture on the right side is where you guys, that is academicians, appreciate it. So connective density should be high. For some user experience should be high. For some, mobility should be high. I am in Bangalore. I am in a flight to Mumbai. There should be, I am talking all the way while, not a flight, I'm driving. So all the way, all through from Bangalore to Delhi, I'm driving, but I'm having a conference call with, say, Narendra Modi ji or Prime Minister of the country. It should be seamlessly, mobile handover should happen and it should work seamlessly. So mobility, hundreds of kilometers, it should be given. Then network efficiency, spectrum efficiency, all that. So all these parameters were considered and 5G is defined. So with that kind of a premises and giving how 5G is, let's get into the protocol architecture of it. What is it and how telecom industry seeing such a huge business cases for them, how they are opening up, how they agreed, okay, fine, I don't have to be proprietary. Even being open, it can be a win-win. What we call it in the industry is 1 + 1 is not equal to 2. What is it? I know you guys have to answer it. Sorry that we are not face-to-face so that you can answer me. 1 + 1 is 11, right? Data center industry and telco industry converging together with all these ideas and experiences, they're opening up, making it open standards. So 1 + 1 is going to become 11. The business use case rapidly expands and creates a new world order. That's what. So now, but at the same time, just because I am seeing 5G to be a fantastic idea, we are all converging, it doesn't mean that 4G guys will not be allowed to port. Things will not work. That should not happen, right? We should support the guys who are already in 2G, guys in 3G, people already working on 3G or 4G should be able to continuously able to work and also to be able to seamlessly migrate to 5. And that is the key aspect. I can't say, I have come up with a nice magic potion. Amrit I have got. I'll only go with 5G and I don't care about what happened to 4G. I can't do that. Industry doesn't allow you. So how does 4G's ecosystem, the layered architecture, and the 5G's newly defined architecture works hand in hand? And what are the key things that is being brought about at the RAN level, that is the tower level or the radio level, we call it RAT, radio access terminals or transmissions we call. So how the radio should work. And then we have kind of BBU, baseband units. Earlier, all the baseband units were sitting next to each tower. But now with the 5G coming, we are calling it as unbundle the RAN, we call it. We are breaking the distributed RAN, DU, and the centralized RAN. We are breaking the RAN into multiple parts, trying to make it containerized applications where I can run some in the cloud, some on the local next to the tower. Some I will converge 100 towers and make one centralized, we call it as a local data center or a LDC, and then move some to the cloud or centralized and virtualized. So I want to segregate the protocols into different layers. So unbundle them, virtualize them, and not only that, now when you call it as massive MIMO and a small cell, earlier if they were in Bangalore, if there were 10,000 towers, now it's going to go 3 times or 10x times, right? Because the range that your tower can reach in millimeter wave is distance wise, it is less reach. So earlier, if you had only 2 towers from Vijayanagar to Jayanagar, if you had 2 towers, now you need to have 5 towers. I'm just giving you an example for you to visualize it, because the reach from a 4G signals for a millimeter wave is less. You need more towers. So once I have more towers, I can't have more people sitting at every tower to manage it if there is any problem. If a tower goes down, network connectivity goes down, I should be able to manage it from the cloud, centralized management. And it should be programmable remotely. So programmable RAN from a remote, from a single UI. I might be in Hawaii, I might be in Delhi, I might be anywhere. Geo central location might be in Mumbai. From there, you should be able to manage a tower sitting from there, the Jayanagar tower, and not only Jayanagar tower. In the generator, there could be multiple antennas. I should be able to manage vertical antenna and change its direction or increase the dB, decibels of it. Can I do that? Is it programmable that level? Is the kind of questions that people are asking these days. So, and then network slicing and what are the different use cases that brings in. So fantastic. Maybe it's another session by itself. So with that layered architecture, if you want to zoom in and see how is 4G and 5G working and what are the new protocols that's coming in, right? Earlier, it is to call as G node B, E node B as BBU unit. Now we call it as generic or next gen node B, as we call it, BBU unit. And again, that is being split into different layers, as I called it, DU, RU. RU is the radio unit. Then next DU is the distributed unit, where distributed units can manage 10 or 20 towers or antennas. And now 10 or 20 or hundreds of distributed units, I can consolidate on a central unit, CU we call it. And all that is still in the RAN architecture within this. Now I'm trying to split them. And for doing all this, a new protocol was brought in. Can you tell me that? Because you are in the R&D space or education space. CIPRI was the old protocol for 4G. eCIPRI came in, Ethernet-based CIPRI, Common Public Radio RAN Interface, whatever you want to call it, right? And that is another innovation. I want you all to appreciate this kind of innovations, because when you explain it to the team or ignite the minds of youngsters, I want you to bring in these aspects of it. So they get enthusiastic and they start looking at, oh, this is so wonderful. A small change can bring in such a huge difference, right? And that is on the RAN aspects of it. Now coming at the core, 5G core, there are 2 things always. I think you're all very familiar. I don't have to dwell much here. Core and the RAN. RAN, a lot of innovation happening, distributed architecture and all that. Core, you can always run anywhere, either in the cloud or in private data centers, like how Airtel or AT&T is to have a captive data centers, their own data centers. You can run it. But earlier they had MME and service gateway or P gateway where data transfers is to happen. The same thing now again they are made it into container based applications where it can run on the cloud or on a single server. And single server could be the server that you just went to SJP Road and bought one server and run your AMF. It will work. That's the beauty of it. Now, how best it will work, it depends on your configuration, but you are allowed to bring in any hardware. COTS, commodity off the shelf, we call it. AMF is access and mobility management. UPF is user plane functions, data traffic that goes out. SMF, SPF is a wrong typo here. SMF, that is service level management, policy applications. And earlier you had subscriber, HSS. And subscriber is being managed by unified data management, we call it. That is, do you have the currency? You don't have the currency? How much of bandwidth you are using? Are you allowed to do video calls or not? All that things, unified data management, right? So this is kind of, and UE is user application, user equipment. It could be your set-top box. It could be your mobile phones or CPE, we call it, consumer applications, we call it, or it could be anything, sensor device, a street camera or a house camera, security camera also, because people are putting camera, connecting to the internet on their mobile. They are able to see any intruder has come to their house or not when they're in a Hawaii celebrating with their family, right? So this is the kind of protocol architecture. If you want to deep down, we can spend days on it. But yeah, I think I overshot big time. Sorry for that. Coming to the last slide, after that I'll hand over to our architect. So how is this being deployed? What is the real use case? What is Dell doing? What is Microsoft doing? What is Oracle doing? What is AWS, Google? What are they trying to do? They are trying to do a data center level of application deployment scenario in collaboration with people like traditional telco vendors, like maybe Jio or AT&T, Ericsson guys. Ericsson guys, they all have core applications. They have far edge, local edge, I used to call. Far edge, local edge could be your CUDU or RAN or Jayanagar Stadium kind of deployments. You could have far edge, could be centralized. All Bangalore is centralized. CUs can be running here, but all your core applications can be running in the cloud or Geo, depends, right? So you should be able to orchestrate sitting in your home in Hawaii or in New York or Amazon, wherever you are sitting, you should be able to deploy all this. So you give me the IP address of your camera or your antenna and all the servers along the way from the antenna to all the servers, commodity servers. Again, I should be able to send the right firmware, right BIOS, right applications, right OS, right drivers, all that sitting somewhere on the top of Himalayas. I should be able to load and make sure that the guy walking on or sitting in a BMTC bus, his mobile is updated with the right Android application OS. Android. So you'll get a message, right? Upgrade your mobile phone OS. That kind of a message is working fine or not on, say, Santosh or Ananth or Kiran, anybody's mobile. Is it fine? Can I see a single pane of glass? If one is able to see, one is able to manage and upgrades to do it. And if something goes wrong, can I still repair and work it and bring it and reboot and get it back? So system integrators, we call it, end-to-end solution integrators. So it's a massive deployment, but how I can achieve it, how I can do it, and coming together of all the world together. I think I gave you a brief overview of how the evolution happened, and I will leave it to our architect Santosh to take you through how are the different world, how you can make best use of it. Santosh, would you like to take over from here?
Ananda, it was wonderful. I hope everyone had some glimpse of the evolution towards a revolution. So guys, you guys have any questions, please let us know. We are here to help you guys and we are here to collaborate with your teams and make sure that you guys are aware of what is happening in the industrial standards, how we are going to see. Basically, theoretically, everyone can talk about architecture, which Anantha is explained now. So the architecture is there, but how we are going to use it and what are the different use cases which can be used. So that is what we wanted to enable you guys, so that you guys are really, when we are talking to your students, you should be making sure that they are into the present world and making sure that they know what is that what they are trying to read and what they are trying to understand from this world. So maybe we are in a short of time, so I'll just go through a couple of insight about it. Let me share my screen. If you
Okay.
can interrupt us any point of time. So
I,
let
I
me
just
share.
stopped sharing, Santosh. Yeah, cool. Thank you.
Yeah. You guys able to see my screen, right? I am starting from your scooter, your bike, Ananta.
Yep,
Okay.
yep. Great.
Okay. This is what the 5G is going to enable us. This is what speed is one of the key factor. So if you see the typical use cases, right? This is what is a smart city, which the government is always looking for. So how with our 5G, right? Our 5G is going to help us to understand this and achieve this. So if you see here, all the use cases are wherever you see the 5G, right? The network slicing, where we slice the data incoming data into different and make sure that the reachability and all those things are being achieved. And we have something called industrial automation, where we are going to apply this 5G. And there is something called a healthcare, where it's very quite low latency is low latency is the major part of it, which is required for us to make sure that we are industrial enabled. Because so we cannot just go into the industry with whatever we have with the high latency, or whatever we have the, as Ananta was rightly mentioned, the areas of concerns are being addressed. If it is a huge data at the stadium, is their speed is very important. Wherein in the healthcare or in automotive industry, latency is very important. The signals what we are going to deliberately make sure that we meet their SLAs. So in 5G, that is a huge challenge, because we are having a converged network where we need to meet different SLAs for the different industries. So the top industries, right, which we have for the 5G have been talking. What we are talking now is going to be basically to intend to increase the transmission speed and the network capacity, and also reduce their latency with respect to the healthcare. So this is what we have already. So if you can see here, I think Ananta would have already spoken about it in a different way. So if it come to the business use cases, right? So these are the criticals, the bullets where 5G is going to be applied. Okay, so if you see that, what is the technology? What is the technology which is making this to be happening, right? So, for example, in 5G, what we have is a lot of performance benefits, which are creating a new opportunity, right? So, what are the different characteristics of it? What, for example, the requirement is we need to be reliable, like a wired, and we should be low latency, at least as Ananta has told, right, less than 20 milliseconds for the industry. And also we have something called GBPS data rate, where we need. So how do we achieve this? So what we are doing is, so what we use is called orthogonal, we call it as OFDM, which is orthogonal frequency division multiplexing, which also which is the algorithms what we are using. Also, we are trying to use 5G NR, which is 5G new radio, which allows us flexible carrier spacing. And also we have something related to multi bands, which is a key reliable long distance in communication. And also we have ultra low latency connections across short distances. So 5G uses all of them, like high, medium, low bands, to ensure data is transmitted across most efficient path. Okay, so that is the best possible way we can achieve all these benefits which are coming from the 5G spectrum. and where it meets their specific service level agreements and their uptime requirements and their business objectives. Okay, so when organization owns the spectrum licensing, the infrastructure and devices, they gain the control over their cellular resources, and they are able to shape up those resources to meet these kind of the sections which I told right away. Okay, so let's talk about what are the different use cases here. So let me take one of the example with the interest of time. So the industrial IoT, right? So what is that industrial IoT is required? So what is, okay, this is something which industrial IoTs cannot afford the process downtime, right? And replacing the machines which are often very expensive and out of questions. So instead of that, manufacturing want to use these IoT sensors to help them the new insights, okay, on an old machine itself, and make sure that they send the alerts for the maintenance when the problem might be on the horizon. So the IIoT sensors requires continuous the access on the system, wherein uh, wherein we can leverage for private 5G, which is another topic to discuss in a deep dive. But we can use the private 5G. Are you guys able to hear me?
Yes, Santosh, I'm able to
Yeah.
hear.
Okay, so enable the factories to build exact network what they need to support their sensors and their technology. So strategically planning the cellular network or the business requirement, right? Their plans are free from whatever the service levels they are being met. So private 5G is the one which is going to rise to the standards what is required. So some of the key use cases from there, right? So they are from the preventive maintenance through IoT sensors, and what we are going to do with the productivity and performing monitoring. And also we are going to meet their internet connectivity with their legacy machines without there is any replacement. See, that is what Anantha was telling, right? So we have to be backward compatible. We cannot just go and tell them, oh, use this machine, and so that you are 5G enabled. So we cannot do that. So what we have to do is we have to also take care of their backward compatibility on their legacy machines. Okay, and also we have to introduce some kind of a robotic technologies where which can remotely make sure that there is no delay in the interference. Okay, so these are the key areas which this private 5G is going to enable us for the industrial IoT. Okay. I just wanted to bring in this slide so that we are in from India, so we are agriculture based country where we need to see large business use cases revolve around agriculture. So what was past? So where there was a lot of GPS trackings, right? And there was a lot of bullet cart. If you see the past, right? So how it was in way back in 1980s. And so now what is the present? Well, we have mobiles, we have a lot of data around us, but farmer is little confused what to use and where to use, right? So bringing in the new technology along with the IoT, what we are bringing here? We are bringing here the stations of the weathers and whatever the plant sensors, right? What the growth of the plants, how they are making sure. See, these are all need the high speed internet data, and make sure that the data is going to be collaborated with, as Anantha was telling, right? The data center and the telecom is converged now to the future, wherein we can achieve lot of use cases with respect to the farming. Okay, so this is all about the use cases which we are talking about, right? So what is there for the future? What is there for future? For example, if you see here, so we are evolving as a 5G, right? We are evolving. So what we have expected to do a faster and more reliable connectivity, allowing more devices to connect to the internet, and enabling new technologies, and make sure that we reach something like 10 milliseconds. okay, with respect to connectivity. When it comes to communication, so we are expected to be more efficient and between the machines and the people, what we are using, and it will also lead to the better collaboration, coordination within organization and among the consumers, okay, who are going to use. So, and we have something called experience here. So user experience, the consumer, right, is going to play a critical role with respect to the future. So wherein the virtual or the augmented reality, right, the video gaming and audio augmented reality, there is what the experience matters. So we are still, means the 5G is still trying to enhance those experiences, okay. And also the very critical part of it is like the productivity. So we are here to do the business, right? So we are here to do some kind of an automation. So we are here to do the productivity in an efficient way. That's where the continuous deployment and continuous integration coming into the 5G. So this is the area where a lot of improvements are happening in the 5G. Okay, and we are all, as an industry experts, we are also eagerly waiting for those kind of an algorithms, so which can go into the market where we can support the high quality and the new services, right? So offering for the customers. Yeah, I think that's all about it. Any questions, guys? You guys have? We can talk about it as Anantha was telling. We can talk lot of things about network slicing, and if you guys are interested, maybe in I can talk to the management and understand the requirement on this. That's all from our side. Thank you all.
Dear participants, any questions or queries?
Yeah, as they think through, right? So the ways, it is something like how we started off this whole session, right? 2G, 3G was like assembling an airplane. 4G was like getting the airplane to the airport, and 5G is airplane is on the runway and about to take off, and you're in the right spot at the right time. You get in this bandwagon, create a lot of innovations on the possible, and that will help you to fly in the air at maybe 20,000 altitude, 30,000 feet above the sky, fly.
So we have one question.
Sorry?
We have one question from the audience.
Okay.
What they are asking is, so the evolution is okay. Okay, evolution is a very good question. So evolution is all okay, but what is the impact on the environment? So how we are going to manage that?
Perfect. I'll share my thoughts. Maybe Santosh, after that, feel free to share, continue. So heat, I am thinking you're looking from the mobile phone. If you talk for an hour, what is the heat? One question could be that is what you're meaning. Other is there was a big issue, right? Birds are dying and all that. That's another kind of high frequency bandwidth. So there are two kinds of things. One is heat and then high frequency, and that will again generate heat, or maybe few animals or birds may be not able to manage that high frequency with high energy, right? When you decibels will be very high. You can't manage it. So to answer that question, very, very rightly said, any engineering technology has this kind of challenges. It is up to our innovation to work on it and try to mitigate it, right? So one is, yes, if you are having a lot of macro cells, a huge number of towers with so many small cell antennas, and if you want to make it reach to a large number of meters, like I think the challenge they have is 500 meters, sorry, 2 kilometers, 3 kilometers. So then you have to pump out the radio frequency at a higher energy when you're pumping from your radio station, right? So can I reduce that? So the idea is a small cell. Have small cells at more cells at a smaller distances than having huge towers with very high energy, so that it will harm the people around it. Instead of the small ones, maybe they can tolerate. Your little things, thick skin, little. So that is one solution people are looking at. Another one is cooling systems. Even the hardwares are getting heated up, right? And what is Dell doing here? Dell, we want to give commodity of the self servers, but telco grade servers. Telco grade servers, what do I mean by telco grade servers? A normal servers that is sitting in the AC room, data center, if you got a chance to go into a data center, right? All full AC. And people wear some mask and all earlier. Nowadays, normal people can walk in, but everything is temperature controlled. But towers are not inside the data center, they're outside. It could be in Rajasthan, wherever sand dunes are there. It could be in Kerala, or it could be in your Ladakh. There also military people need towers. That temperature varies from minus 20 degrees to maybe 60 degrees, 70 degrees, 80 degrees. But your server has to work everywhere. Because suppose I'm just giving an example, some other country is attacking India, suppose, and you are in a high range altitude of Himalayas. If the tower goes, you can't communicate, right? Our defense becomes weak. Communication is critical. So there also, how will your hardware sustain different temperatures, different heat? At the same time, how do you manage a different power? So innovations have to happen. We have just begun. That's why, as I said, aeroplane has come to the aerodrome. It is on its runway. It is yet to take off. And we want young brains, young talented folks to come in, innovate, ask this kind of right questions, and solve this for the industry. And that's why the whole shift is getting into, if you say India's push or the whole G20 push is going into green energy. Instead of really going in, can you get into solar? Can you get into hydro? These are the kind of solutions also. I think I answered in a very broad way. So Santosh, if you want to.
I think it meant a lot, okay, for them. And also what I wanted to tell is there are a lot of inside researches are been happening, wherein as he said that the introduction of the small cell capability. So we are actually reducing with respect to 4G. If you compare 4G and 5G, actually we are reducing those kind of an impact on the environment. Also, there are a lot of research are going associating with the network, right? Whatever the network, if you see the containerizer environment, we are already reducing number of devices which are going to be part of your infrastructure. So the infrastructure is going to be the cloud native way, which actually stops using multiple devices, which generates heat and it consumes a lot of energy. So that is one area which is a lot of research is going on. And one of the solution what Anantha was telling about the cloud native infrastructure, which is going to be shared on the shared base. So we are not, and also another important point is the SLAs what we are going to meet. Based on that, we are going to introduce those infrastructure into the domain. So that is also going to impact on the and on the environment. So that is still working on. So I understand there are a lot of questions arrived with respect to the technology. So incrementing with the environmental not friendly, but we are trying to reduce on a one way, so that the compatibility of the pendulum is on the same side.
Yes, thanks, Santosh. So it is good to have problems, right? So it is not that we have solved all the problems. And the day you feel that you have solved all the problems, then we become lethargic. There is no innovation happening. So it is beautiful, nice to see the questions coming in. And we are not claiming that we have solved all. Huge scope for solving. Let's collaborate. Industry, R&D, and educational institutions, young minds, startups. Let's come and solve, and let's solve it in a very organic way with trying to that's how the technology evolves, industry evolves, and human evolution evolves. So
yeah, so the interest of time
sorry.
yeah, so we can conclude this meeting. Thank you very much for your participation. Any questions or any further requirement from us, right? Please let us know. We'll plan accordingly.
Thank you so much, everyone. Thank you, Santosh. Thank you, facilitators. It was wonderful talking to you all. Happy Ganesh Chaturthi in advance. So I know you're all preparing for that. Already you have to buy some fruits, flowers, everything for home on your way back home. So good wishes to all. Thank you so much for this opportunity.
Thank you, sir. Thank you very much. We extend our heartfelt appreciation to our esteemed industry experts, Mr. Ananth Prakash and Mr. Santosh Kumar, sir, for joining our faculty development program and sharing your invaluable insights Your expertise and knowledge have been instrumental in broadening our understanding of this cutting edge technology. Thank you, sir. Thank you very much for joining us.
Thank you all. Have a good day.
Thank you.
Thank you,
Thank
sir.
you.
Thank you very much.
Bye. Good day.
Recording stopped.
ಕೊಡ್ಬೋದು.